Okay, let's take a peek. So first of all, what's this angle in here have to be? 45. So when we cut it in half, the angle has to be 22.5, right? And this is 4, which makes this piece here, which I'm going to call y, that's going to be the sine of 22.5 equals y over 4. So I'll put this over 1 and we'll cross multiply and divide. Sine 22.5 times 4 divided by 1. We don't need to do the divide by 1. 1.53 times 2, because it's half of it, 3.06. 3.061, we're going to call it. Is that what you're getting? 1.4? Yeah, 1.5 actually. Yeah. So those are each 1.2 inches. These angles here are each 60 degrees. That would be 6 inches. These would each be 0.8 inches. What I want you to find, well, distance between. See if you can figure that out. Okay, so I gave you the hint with the green triangle there. If we're given that, of course, this is 30 degrees here, correct? And this dimension is going to be 0.6. So we need to find this dimension. So we're actually using a tangent now. Tangent to 30 degrees equals 0.6 over, I'll call that y for now, to find y. So we're going to have to make this a proportion. It'll be 1 times 0.6, which is 0.6, divided by the tangent to 30, giving us 1.039 here. So that's 1.039 inches here. And of course, this will be 1.039 inches here. This is going to be 0.6. And this is going to be 0.6. So what I have is 0.8, 0.8, 1 from each side, 0.6, 0.6, and 1.039 and 1.039. I need to add those all up. I get 4.878. Does that look right? And I will subtract that then from 6 inches. Which will give me 1.122. Is that what you come up with? What do you think? Loads of fun?
It's good when the triangle is there. I have issues finding the shape of sticking the part where I need it.
Oh, sure. You said you had 1.1216? Yeah, I just round off differences on those. And that is the tricky part, is finding the triangle. Here, I'll show you an example here that's kind of tricky in its own way. That's 117. I wrote it kind of sloppy, but find that missing angle. Give that one a shot. On this one. So we'd start out this one up here, drawing that across. Do we know we have an angle? Well, we actually have two angles because we made the right angle here. But do we know any of the sides of that triangle? You can find this one at 21 millimeters. How did I do that?
That's the overall height.
Yep, the 138 is all the way up. The 117 is to there. So you subtract, get 21. So that means we can find this dimension right here using a tangent. If I call this here x, tangent of 72 degrees equals x over 21. Because x would be the opposite side compared to the 72-degree angle. So I'll put this over 1. It's going to be tangent of 72 times 21 divided by 1. Again, I'm not going to bother dividing by 1. So tangent of 72 times 21 is 64.63. So that's 64.63 millimeters here. Which means over here, again, maybe not quite drawn to scale. If we subtract from the 200, 200 minus the 64, this is 135.37 millimeters. So now that makes this right here the inverse tangent of the opposite side of 117 over the adjacent side of 135.37. So second tangent, 117 divided by 135.37. 40.84 degrees. Anybody have that? Everybody see how to get it now? It is tough. I mean, it really can be tough to see the triangles in these.
Can you split it the other way? Connecting the two angles?
From here to there? Oh, from here to there?
Yeah, that's what I did. Yeah, that's what I did too.
If you do that, you've got a right triangle and you have two sides. You could find the distance across here. You could find all the angles, which means you could find this angle. So you could have this distance and that angle, but I'm not seeing where you could get a third piece. Because if you do this, of course, now you can find this side, this angle, this angle. So you'll have this side and you can find this angle by subtraction, but that's the only information I can see that you would have. You'd have one side and one angle. I don't see where you'd find anything else.
You split the left side again into a 90 degree?
Here? Yeah, but then if you can split that into a 90 degree, but you don't know how that angle breaks down or how the length of the side breaks down.
You can figure it out though, because if you draw from the
From here?
perpendicular to the blue line, yeah.
Like this?
Yeah. So now you know.
You know this angle here, you know that angle. Well, you know this angle, but you don't know any sides. Because this side doesn't stop there, it goes all the way down. You don't know the partial length of the side.
But if you know all the angles, you don't need to know any length.
You gotta have at least one side, at least one length.
If you know the three angles in this triangle, you can find the three angles in the triangle that isn't defined yet.
Over here?
Over there.
Still have to have a side somewhere.
Why?
Because without a side, they're similar triangles, they're not equal triangles. Because they can be magnified or reduced, enlarged or reduced, and still keep the same angles. Got to have a length somewhere. You can work with all three sides, but you can't work with just all three angles. Okay, this next one's a fun one. What's that? Find x. So if I give you that's 82 degrees, that tells you those two sides, those opposite sides have to be parallel. That'll make it easier. Okay, so when we go to divide this up, we're running out of time, so I'm going to go ahead and finish this off. We don't make a right angle. We make this at 98 degrees. Why do we do that? Because if we made it a right angle, we wouldn't know what this side is. We know that this side, if we make this parallel to this side, we know this has to be 42, which makes this up here 29 millimeters. So now what we have is we have all three angles, because that's 98. This is 67, which would make this one here 15 degrees, right? And now we can find x, because 29 over the sine of 15 degrees equals x over the sine of 98 degrees. Gives us 110.96, no, 110.957. It is way easier than it looks, but you've got to see that not making right triangles here, just making a parallelogram. Try to make right triangles. This one is really agonizing. In the packet that I gave you a few days back, starting on page 385, going through like 389, I believe, 389, there are some review problems. Achievement review, they call it. Tomorrow morning, of course, is our test, unit test. Finish off the week with a bang. Any questions?